Hello again. So the goal for this problem is to derive the derivative formula for the inverse secant function. And our first step is going to give it a name. We're going to call it y is the secant inverse of x. Our next step is to take the secant of both sides of this. So the secant of our function y is the secant of the secant inverse of x. And because those are inverse functions, we're going to have the statement secant of y is equal to just x. As before, we're going to differentiate. The derivative of the secant function is the product secant tangent. So this is going to become the secant of y times the tangent of y times the derivative of the inside, which is y prime. And that's equal to the derivative of x, which is 1. So again, just to kind of recap, we took the derivative of this equation and arrived at this statement here. The next step for us is to go through and solve for y prime. So y prime is going to be 1 over the secant of y and the tangent of y. And then just like before, we want to go through and express the secant and tangent functions in terms of the variable x. And in doing so, what we're going to do is take a look at what it means for the secant of y to be equal to x. So off to the side, if we know that the secant of angle y is equal to x, it's the ratio x over 1. And we can now use some trigonometry to make this more friendly. So we'll take the reciprocal of both sides of this, and that's going to give us the cosine of angle y is equal to the ratio 1 over x. And now we'll draw a right triangle that has this information. So we're going to have our angle y inside of the triangle. And remember, cosine is adjacent over hypotenuse. So that makes our third side the square root of x squared minus 1. And we now have our information to decode this. So going back, we're going to have y prime is equal to 1 divided by the product secant of y times the tangent of y. So y prime going to be 1 over, and remember that we had the secant of y equaling just plain x, so that's going to be an x, and then we're going to have the tangent of y as our opposite over adjacent, so that's the square root of x squared minus 1 over 1, and we're not going to write the 1, but we'll just have it there now as a placeholder. And it's very important to understand that since we're working with the first quadrant, we don't want to have any negative values of x. We want to have a positive derivative. So therefore, we have to put absolute values on our x to require that it's positive. And remember, y prime this whole time is the derivative of the inverse secant. So this tells us in summary that the derivative of the inverse secant function is equal to the fraction 1 over the absolute value of x times the square root of x squared minus 1. And that is the derivative formula for arc or inverse secant. And again, we just have to use what we know from trigonometry and calculus to put it together to get this derivative.